Dear students, greetings for the day. In the previous class, we learned about the gas laws, ideal gas equation. And in this class, we shall know about isothermal process and adiabatic process. So in the previous class, Boyle's law states that the volume of a given mass of gas is directly inversely proportional to its pressure at constant temperature. So Boyle studied the relation between pressure and volume, keeping the temperature constant. So in isothermal process also temperature is constant. In Charles' first law, Charles studied the relation between volume and absolute temperature, keeping pressure constant. He observed that volume of the given mass of the gas is directly proportional to absolute temperature of the gas at constant pressure. And Charles' second law, at constant volume, states that the pressure of a given mass of gas is directly proportional to its absolute temperature at constant volume. So from Boyle's law, volume of the given mass of gas is inversely proportional to its pressure, or PV equal to a proportionality constant K. From this, if a gas possesses volume V1 at pressure P1 and volume V2 at pressure P2, then P1 V1 equal to P2. So isothermal process obey this equation. And Charles' first law, he observed that volume of the given mass of gas is directly proportional to the absolute temperature of the gas at constant pressure. Therefore, V by T equal to constant. Or if a gas possesses volume V1 at temperature T1, then V1 by T1 equal to, if a gas possesses volume V2 at temperature T2, then V1 by T1 equal to V2 by T2. And from Charles' second law, the pressure of a given mass of gas is directly proportional to its absolute temperature at constant volume. From this, P by T equal to constant. Or if a gas possesses pressure P1 at temperature T1 and pressure P2 at temperature T2, then P1 by T1 equal to P2 by T2. Now, by combining the first two laws, that is Boyle's law and Charles' first law, we obtain the ideal gas equation. A gas which has a molecules of finite size and negligible volume, then and obeying the Boyle's law and Charles' law at all temperatures and pressures, then the gas is known as ideal gas. So a gas which follows Boyle's law and Charles' laws at all temperatures and pressures is known as ideal gas. So ideal gas equation, ideal gas follows the ideal gas equation. It is obtained from these first two laws from statements. P is proportional to 1 by P into T. From this, V is equal to some constant into T by P, or PV by T equal to constant. This constant value is equal to For 1 gram molecule of gas it is equal to R, or for n gram molecules it is equal to NR. Therefore, we write for 1 gram molecule of gas, we write PV equal to R for 1 gram mole of. Therefore, ideal gas equation is this one. And in another method, ideal gas equation is also derived as P1 by T1 equal to P2 T2 P2 V2 by T2. So in terms of density, this equation is written as since volume is proportional to mass by density, therefore at density d1 volume is v1, then d1 is equal to m by v1. And at density d2, if volume is v2, then v2 is equal to d2. By substituting the values in this equation, we get v1 by d1 t1 equal to v2 by d2 t2. This is the ideal gas equation in terms of density. So any gas possesses certain pressure and volume at 0 degrees centigrade, and on increasing the temperature its pressure and volume increases, but by keeping the one quantity fixed. For example, we study the relation between pressure and volume by keeping temperature fixed. So if we supply energy, then its volume, if pressure decreases, volume increases. If pressure increases, volume decreases. So as the name indicates, isothermal process. First we shall discuss isothermal process. As the name indicates, isothermal, a total amount of heat energy remains constant. Thermal means heat. So iso means same, remains constant. That means, therefore, if we consider a piston in a cylinder which is made up of conducting wall, wood conducting, if we consider vessel, metallic vessel, metallic pump, so in which some gas is enclosed in it, let there be piston. It has certain volume V. If we increase pressure, so here if we decrease the pressure, then volume increases when temperature remains the same. So when pressure decreases, volume increases. This is known as isothermal expansion. So in isothermal expansion, if pressure decreases, volume increases at constant temperature. And if piston is pushed inside, then pressure increases. In this case, pressure increases, whereas the volume decreases. Volume decreases. This is called isothermal compression. So when pressure increases by pushing the piston inside, volume decreases, and here, as the pressure and volumes are inversely proportional to each other, here Boyle's law holds good as temperature is constant. Therefore, isothermal process is a process in which there will be change in pressure and change in volume at constant temperature. So here, as temperature remains constant, for examples of isothermal process, a gas enclosed in a metallic cylinder is taken as example. When we pump the air by using metallic pump with a piston, when the piston is slowly moved and when it is when we apply pressure on the piston, then volume is slowly decreasing and pressure is slowly increasing, but temperature remains constant because the system or gas is enclosed in a good metallic cylinder. If there is any increase in temperature, it is absorbed by the surroundings, so that temperature remains constant. And the propagation of longitudinal waves also takes place at either isothermal conditions, but it is not correct. Later it is proved it takes place under adiabatic conditions. And adiabatic process. Let us know the definition of adiabatic process. Adiabatic process is the process in which there will be change in pressure, change in volume and change in temperature. So in this process all the three thermodynamical variables change because the system is enclosed in a non-conducting vessel or it is enclosed in non-conducting vessel, so that if there is any change in temperature, then there will be change in pressure and volume also. So here in this case heat energy does not transmit it to the surroundings and it remains constant. So internal energy remains constant in this process. So the process in which there will be change in pressure, change in volume and change in temperature is known as adiabatic process or adiabatic change. So a process in which there will be change in pressure, change in volume and change in temperature is known as adiabatic process or adiabatic change. This is isothermal change. Now let us know about adiabatic expansion. If temperature increases, then either pressure and volume are increases. So when we consider the system or gas enclosed in a metallic and non-metallic cylinder or insulating cylinder, then if temperature is raised, there is change in pressure and volume. So if a piston expands then it is known as adiabatic expansion. If the piston comes down and volume decreases, then it is known as adiabatic compression. The examples for this adiabatic process is taken as the bursting of air in a tube when it is pumping. All the three are changes. And when we take a pump made with wood and when the piston is suddenly moving, then it's in that case temperature increases, pressure increases and volume decreases. So all the three quantities PVT changes. So it is an example of adiabatic process. And the propagation of sound waves in air or longitudinal waves propagating in the air are an example of adiabatic process. At adiabatic conditions, sound waves are propagating in the air. Now let us know the differences among the isothermal and adiabatic changes. So distinction between isothermal process and adiabatic process, or isothermal change and adiabatic change. First point is nothing but definition. So a process, an adiabatic process, or a process in which there will be changing pressure, volume, and temperature is known as adiabatic process. A process in which there will be change in pressure and change in volume at constant temperature is called isothermal process. And second point, it is a quick process. It is a slow process. So when we take gas in a non-conducting cylinder, and when we move piston inside fastly, then there will be change in pressure, volume and temperature. So it is a quick process. When we move in conducting cylinder made up of conducting metal, if we move slowly piston, then only here temperature remains constant and pressure and volume changes. So it is a slow process. Third one, temperature is not constant in this. All the three changes. Here temperature is constant. So in isothermal process, temperature is constant. In adiabatic process, temperature is not constant. All the three quantities, that is temperature, pressure, volume, changes. So as temperature is not constant, internal energy is not constant. Internal energy changes in adiabatic process. So in this internal energy remains constant. So any gas, we know that consists of molecules which are in random motion. So they possess internal kinetic energy, and due to the molecular attraction forces between the molecules of the gas, it possesses internal potential energy. So the sum of internal potential energy and internal kinetic energy called internal energy of the gas or internal energy of the system. It is measured in joules. So here internal energy in isothermal process remains constant. Internal energy of the system changes in the adiabatic process. And fifth one, it obeys Boyle's law. So here Boyle's law not holds good. It follows Boyle's law. or Boyle's law holds good. Therefore, PV equal to constant not holds good. Here, PV equal to constant holds good. But in adiabatic process, PV to the power gamma equal to constant holds good. Where gamma equal to Cp by Cv, ratio of specific heats of the gas. Here PV to the power gamma equal to here PV equal to constant holds good. Boyle's law holds good. So adiabatic process is a quick process. Adiabatic isothermal process is a slow process. In adiabatic process, temperature is not constant, and pressure volumes are also changes along with the temperature. But in isothermal process, temperature is constant, but only pressure and volume changes. In adiabatic process, internal energy of the system changes. So gas internal energy changes. Your internal energy remains constant as temperature remains constant. Here Boyle's law does not holds good. Here it obeys Boyle's law, it follows Boyle's law. So PV equal to constant not holds good for isothermal process, but PV to the power gamma equal to constant holds good. But in isothermal process, PV equal to constant holds good. Therefore, for this P1 V1 is equal to P2 V2 equal to constant K. Next, in adiabatic process, exchange of heat is not allowed between the system and the surroundings. But in the case of isothermal process, heat is exchanged between the system and the surroundings because the system is enclosed in a good conducting vessel. So, exchange of heat energy not allowed exchange of. Yeah. Exchange of heat is allowed in isothermal process. So in isothermal system, the gas is enclosed in a metallic vessel. Therefore, temperature, if any heat energy increases, to keep the temperature constant, heat flows to the outside, to the surroundings, and if it is necessary, it absorbs the energy, heat energy from the surroundings. So exchange of heat is allowed between the system and the surroundings in the case of isothermal system, but in the case of adiabatic process, exchange of heat is not allowed between the system and the surroundings because the system is enclosed in non-conducting vessel. So these are the differences between the isothermal process and adiabatic process. And example of adiabatic process, when we pump the air in the tube, then its volume increases, pressure increases, and temperature is also increases. So it is an example for adiabatic process. And propagation of sound waves in air is also example for adiabatic process, where all the three quantities change at compressions and rarefactions. Temperature, pressure, volume changes. And in for isothermal process, the gas enclosed in a metallic cylinder with a slow moving piston is an example for isothermal process. When we slowly move the piston, then volume decreases and pressure slowly increases, but if any increase in temperature, it is absorbed by the surroundings, so that temperature remains constant. So heat energy is transferred to the surroundings, temperature remains constant. So it is an example of isothermal process. So a process in which there will be change in pressure and volume at constant temperature is known as isothermal process. A process in which there will be change in pressure, volume and temperature is known as adiabatic process. So in isothermal process temperature is constant, in adiabatic process temperature is not constant. All the three thermodynamic variables, pressure, volume, temperature changes. And Boyle's law holds good for isothermal process, and Boyle's law does not hold good for adiabatic process. PV equal to constant holds good for isothermal process, and PV to the power gamma equal to constant holds good for adiabatic process. So from this P1 in isothermal process, P1 V1 equal to P2 V2, whereas in isothermal process, adiabatic process, P1 V1 to the power gamma equal to P2 V2 to the power gamma equal to some constant K. And the exchange of heat is not allowed between the system and surroundings in adiabatic process, whereas in isothermal process, exchange of heat is allowed between the system and the surroundings. And internal energy in adiabatic process remains constant, whereas in isothermal process it in isothermal process as temperature is constant, internal energy remains constant. In adiabatic process internal energy changes because all the three EVT changes, but heat energy remains constant in adiabatic process, whereas heat energy is not constant in isothermal process. Now let us derive the expression for external work done by the ideal gas. Consider a 1 gram molecule of ideal gas which is enclosed in a non-conducting vessel. So let the initial volume be V1, that is from this part to this part, A to P. Now when when we supply the some heat energy, when we heat its temperature increases, then at constant pressure, then here volume of the gas increases. When we give temperature, when we heat the gas, then some force is acting on the piston as the molecules are moving with higher velocities. So pressure increases and so that volume here increases. So let the final volume be V2. And this piston moves to this side. So this distance is equal to, let it be dx. Distance traveled by the piston B. So let the force applied by the gas be F bar. Let the piston of area, if it is circular piston, pi r square, or if it has length and breadth, then area of the piston be L, length into breadth. So consider 1 gram molecule of gas. Ideal gas enclosed non-conducting cylinder. Having initial volume on heating the gas, raising the temperature from T1 to T2, on supplying the heat energy to the gas or system, let the piston of area L equal to B r pi r square. If it is circular one, moves from B to C. Here some force is there, some displacement is there. Therefore force on the piston and the displacement work done by the gas. Work is done by the gas. Work is said to be done. Work is done by the gas. Therefore work done is equal to work done by the system or work done by the gas. This will be W equal to force into at pressure P, force into displacement. This is force on the piston. Therefore, force on the piston, from the definition of the pressure, P is equal to force per unit area of the piston, force acting on the piston by area of the piston. Therefore, pressure P, from this F is equal to PA. Therefore, pressure into area of the piston into displacement dx. This area into displacement is nothing but volume. Increase in volume. This area of the piston into this dx, displacement is nothing but height. Area into height is nothing but increase in volume. Therefore, P into increase in volume. Or P into, let this be volume V2, when it changes to total amount of volume is in the new case V2. Therefore, P into V2 minus V1, increase in volume. So, external work done by the gas is dW is equal to PV2 minus PV1. So, consider 1 gram molecule ideal gas enclosed in the non-conducting cylinder, which is at constant pressure P and having initial volume V1. When some heat energy is applied to the system gas, then some force is acting on the pressure and thermal expansion here takes place, adiabatic expansion takes place, and this force on the piston moves the piston from B to C, and volume of the gas increases from V1 to V2. Therefore, as there is some displacement and force acting on the piston here, some work is done by the gas. So, work done by the gas or work done by the system equal to force into displacement, force on the piston into displacement of the piston. Therefore, force is P, F into S, or here F is equal to P into A, and displacement is X. And but when we write this area into displacement, volume, height, this is height or volume of the newly formed block by the moving piston. Therefore, that indicates increase in volume of the gas. Therefore, this is pressure into, therefore, work done by the gas is equal to pressure into increase in volume. Sometimes it is written as dW is equal to P into dV. So, increase in volume is represented by dV. Therefore, P into dV. So, when we consider 1 gram molecule of gas, then having volume V1 at constant pressure P, then if we supply heat energy by increasing the temperature the gas. Then here some force is acting on the piston and the adiabatic expansion takes place and the piston moves from B to C and volume increases from V1 to V2. So here force on the piston is obtained from the formula pressure equal to force per unit area. Force equal to pressure into area. Here we substitute its value as P into A. And therefore here force is there, displacement is there. Force on the piston P into A, displacement is dx. So area into displacement is called increase in volume. Therefore P into increase in volume V2 minus V1, or P into increase in volume is represented by dV. Now let us know the first law of thermodynamics. There are two laws: thermodynamics first law and thermodynamics second law. So thermodynamics first law states that if the heat energy supplied to the system gas, it is utilized in two ways: to increase in internal energy, and the remaining amount of the energy is utilized to do some work. Therefore zeroth law of thermodynamics is nothing but law of conservation of energy. It is equal to W equal to JH. So whenever heat is produced, some work is done. So when we supply some heat energy dQ, then it is increased to increase in internal energy du, and the remaining part of the dQ is utilized to do some work done by the gas. So from the law of conservation of energy, it is written dQ equal to du plus dW. Here dQ is the amount of heat energy supplied to the system, du is the increase in internal energy, and dW is the work done by the system or gas. And second law of thermodynamics states that heat energy flows from a body at a higher temperature to a body at a lower temperature. This is generally takes place. But with the help of external agency, heat energy flows from a body at a lower temperature to a body at a higher temperature with the help of external agency like AC machine, air conditioner, or refrigerating machine. So in the next class we shall continue the class and first law of thermodynamics, laws of thermodynamics and their applications.